Okay, Algebra 1 students, this is a blended lesson from Unit 2, Lessons 10 and 11. There are 2 activities from Lesson 10 and I think 3 activities from Lesson 11. Those are the only things that need to be filled out in the student task statements. So let's take a look at what this lesson, these 2 lessons combined, what is the point of these lessons, okay? So you know that you've been working with equations. We have worked with equations in one variable. We've worked with equations in 2 variables. That's from lessons 8 and 9. And we've rearranged these equations, okay, so that we can isolate or get all by itself one of the variables, okay? So now we're going to tie that process to a graph and investigate how a graph and the equation relate to each other, okay? So let's begin. So here is the warm-up, all right? So they give you a situation. You have been writing equations based on situations for a couple of weeks now since we started this unit, all right? And this is just another one. Jada has $20 to spend on 2 things at a carnival: games and rides, all right? And then they tell you how much each one of those things cost. Games cost $1 each, and rides are $2 each, okay? So then the first questions they ask you is which equation represents this relationship in this situation? Well, they're telling you that games are X and rides are Y, okay? So if games are $1 each, then that means I'm going to be multiplying the X by 1. And if rides are $2 each, I'm going to be multiplying Y by 2. And oh, look at this. This models my situation quite nicely. Okay, games, $1 each, plus rides at $2 each, and here's my $20, okay? And then they ask you to explain what the other 2 equations mean. Well, all that means is, for example, $1 for games, $1 for rides, okay? You still only have $20 to spend, all right? And this equation, here, games are $2 each and rides are $1 each. And then once again, you still only have $20 to spend, okay? So now let's move on to the first activity, all right? So once again, they're keeping the same situation. The same situation. We're going to a carnival. Nice picture of a carnival there. And we have three different relationships between the numbers of games. So they're keeping everything the same. X is games, Y is rides. And the dollar amount is different. Okay? And these are 3 different amusement parks. Okay? And they're asking you to choose one of these to play with in your student task statement. And then they're going to ask you to figure some stuff out. So what is the number of rides a student could get on if they didn't play any games? So if they didn't play any games, that X would be 0, wouldn't it? It would. Okay. So this would kind of go away. This X wouldn't be here. So if they didn't play any games, then all we have to do is we have to deal with the rides. So we've got 3 choices. Well, Mrs. Heinzman, I'm going to pick this one, equation 2. Okay, so if I don't pick any games, then I can go on 15 rides. Okay? So, and if I didn't go on any rides, how many games could I play? Okay? Well, if I didn't go on any rides, Y would be 0, right? Because I didn't go on any. And then I would just need to divide 15 by 2.5, and I get 7. Okay? So now they want us to plot those points on a grid. So on the number of rides, if I don't play any games, see, games are 0. If I don't play any games, I can go on 15. So I would put a mark right there. Up right there. Okay? And if I didn't go on any rides and I just played games, I could play 7 games. So my other point would be right there. And then I would connect those 2 points with a line. Okay? And the student task statements tell you how to do that. All right? So then they ask you to summarize this. Okay? And they ask you where the graph intersects the vertical axis. Well, it intersects the vertical axis at 15, right? We just saw that. So now what they're trying to get you to see is that different forms of an equation show you different parts of a graph. That's the connection here. So I'm going to pause the video and open up the student task statement, show you what happens next, and then we're going to synthesize this lesson. Okay, so let's recall I chose equation 2. So I'm going to demonstrate this for you. So here is, if I don't play any games, I can ride 15 rides. Okay? If I don't go on any rides, so my rides are 0, I can play 7 games. Okay? And when I click on these points, it'll draw a line between them when I click on line. Sorry. So click, click. It'll draw a line. All right, there we go. So now they want me to rearrange the equation, my original equation, and we're going to do that. Okay, so if the student played no games, they can go on 15 rides. And for every additional game that they play, the possible number of rides, Y, decreases, right? Because the more games they play, the fewer rides they can go on, and it decreases by 2.5. All right? So it decreases. All right? Okay. So now they're asking you things like, what is the slope of your graph? And the slope of your graph is the rise of the graph. So how it goes up or down. You can see this graph is going down. So it's how much it goes down and how much it goes to the right. Okay? So it goes down 15 and to the right 7. So that's 15 divided by 7, which if you do that math is 2.5. Okay? So the slope is 2.5. All right? The vertical intercept is 15. All right? And so now they want you to rearrange your original equation. So I'm going to connect this for you now. All right? So I'm going to type the original equation, 2.5x plus y equals 15. Remember that? All right, so I'm just going to isolate y. So how do I do that? See this plus 2.5? I have to subtract it. So I'm going to do that, okay? Minus 2.5x, sorry. And because it's an equation, I got to do the same thing to both sides. So I will. So now I can get rid of all of this on this side because I canceled it out. And this is my new equation. And they're asking me, how do these relate to each other? What are the new connections? Okay? And the connection is that in this form of the equation, this one, the original form, this form right here, in this form, I can't tell what the slope is. And I also can't tell what my vertical intercept is. Okay? I have to figure that out. But when I rearrange the equation so that it looks like this, now all of a sudden I know what my vertical intercept is. I can see it in the equation, not just on the graph. Okay? And I can also see my slope. So thank you for listening. This concludes part 1 of lessons 10 and 11. We're going to synthesize these two lessons in part 2 of this video.